and it's not here. And it's the universal reason that things don't appear in Manim. You have to add them first. Okay, so there's my number line. And now what we're going to do is for the first, before we get to animating this, we'll just do this with a fixed number of heads and tails. So I'm going to have this array flips, and I'll just have the heads be 1s, the tails be 0s. And I'll have something like this. Then I'm going to want to draw a graph from this. So I'll do this in a function called def draw graph. Don't think it has to take anything. I'll just have graph. That'll be a V group. And then I'm just going to go through the flips. And I'm just going to place the dots according to the cumulative probability. Actually, just to make sure I'm doing this correctly, let me just do a graph.add like a dot. And I like to do this just to make sure I'm not getting any syntax wrong. And I'm going to end up redrawing this graph on every frame. So I'm going to use the always redraw function. Let's do graph equals always redraw. And then this will take a function. So it'll be, yeah, I think I can just put draw graph in here. Then I'll add that. So if all of this worked according to plan, you should just see a dot in the middle of the screen. Let's see if that worked. And I did something wrong. I think I need a lambda. This might be how it goes. No, guess not. Wait, am I doing the right thing? I'm trying to add an update. Oh, I have to return it. Okay, so let's try this. Great, let me see that dot in the middle. And I think this is pretty useful because it showed me that that I'm not returning this graph. That might have been a little hard to debug if I wrote a lot of code before I did that. So that's great. Okay, now let me actually draw the graph that I want to. So I'm just going to iterate through the dots and compute the cumulative probability for that point. So for flip in flips, I'm going to create a dot. And I'll just color it. Well, I can deal with the coloring actually later, because the positioning will be a little bit more interesting. So the probability, and I want the probability at the point that I'm flipping this particular coin. So it's going to be, I just commented out first, it's going to be the number of heads divided by the number of flips. And how would I get that at a given coin flip? Well, I'll need the index. So let me put I here and enumerate. Then the number of heads up to this position I will be flips dot count 1. And it won't be all of flips, it'll be flips to I plus 1. So for 0, it won't include the 1 index. Then the number of flips, that's just going to be I plus 1. So for example, the first one, I will equal 0. It's going to count up the flips in only the first index. That'll be 1. It's going to divide that by I plus 1, which is 1. So that should place the first dot at the top here. Okay, so then we can do dot move to. And we'll want to place the first dot at the top here. Okay, so then we can do dot move to. And we'll want to do chords to point. It's supposed to be plain. Chords to point. And the x coordinate will be I. The y coordinate will be the probability. Okay, then I have to add the dot to the graph. Okay, let's see if these are at least placed. And I don't see any of them. So why would that happen? Lane.chords to point, I have the dot here. Then I return the graph. I flip and enumerate flips. I wonder if this, well, to start, I'm gonna comment this and see if I can just have the dots appear in the middle. And that actually didn't work either. So this actually makes me wonder why these aren't being returned in the graph. Draw graph. Here I'm going to print the subobjects of the graph. See if these are being added at all, and there aren't any. What I think is happening here, maybe flips. Oh, well, flip was never accessed. No, I think that's fine. I can actually try to print flips from this. So it does have that. I'm gonna print the graph submodules from here. That's still empty. So what that tells me is that this loop seems like it's not being accessed. So let me see if that's happening. I'll just print I. And it is. Oh, I'm doing dot.add graph. It should be graph.add dot. So that was a pretty silly mistake. But I guess that's the process of debugging for you. So let's see if this places them. Okay. So we can sort of follow through this. And the first one has probability 1. After the second one, there's been 1 heads and 1 tails. So this goes to 0.5. Here there's been 2 and 0. So this is going to go to 0.66 repeating. Then there was 3 out of 4, so this will be 0.75. And so you can see this placing them where they're supposed to go. So now, one thing is I'm going to color them so that we can see the heads versus the tails. So here I'll say if flip is a 1, I'll do dot.set color red. Otherwise, I'll set that color to blue. And those will just map out where the heads and the tails are. So that's fairly straightforward. Now I want to not just do this one time, I want to do this changing over time. So to do that, I'm going to create a value tracker. I'll just call this time tracker. And this is going to start at 0. Instead of doing a wait, I'll play. I'll do time tracker. Animate. Set value. Now I'll put it at 5 or so. Then if I make the runtime 5, animate the rate func be linear, then this is essentially going to make this time tracker just track the length of time of the animation. Then this is essentially going to make this time tracker just track the length of time of the animation. And running that, we see nothing went wrong. Okay, so now I'm gonna pass in the time tracker, the value of the time tracker. Great, and I'll just put in time here. And now I'll be able to grow this array of flips with time. So I'll set this to 0, or make this an empty array. Then I'll say, if the length of the flips is less than the time in seconds, then I'm going to add one. So I'll say flips dot append. I'll do random.choice of 0 and 1. And for that, I'll have to import random. So I'll do that. Random. Okay. Okay, and this shouldn't be an if, this should actually be a while. This is going to make sure if the time exceeds the length of the flips, that it's going to keep adding flips until it matches the time. And I'm thinking if this should be a less than or equal to or not. What would this mean? It does mean if it's equal to the time, it would add one, so I actually don't want to do that. Okay, so let's see if this now is going to grow over time. Great, and so now for 5 seconds, because I set this to 5, this graph is just going to grow over time. Now, that's pretty slow, so I'm going to add a flips per second. Parameter. And I'll set that to 5. Great, now this is going to grow a lot faster. Okay, so that's great. Next, your name is the shade of purple that makes it hard to read. A learner. Hi, what's up? Okay, so now I have the graph growing over time. Next, so you can already sort of see this is growing off the side of the graph. So we'll want to shrink this down so that it always fits on the graph next. So next I'll go through that. Here's the color. Here's the position. And now we're going to want to scale that. So originally, these points are going to be in the range from 0 to t. And then we're going to want to shrink them. So we're going to have a shrink factor rather. It's going to be 10 divided by the time. And then to shrink these points down so that they fit in the graph, we're going to take their coordinate, their x coordinate, and multiply them by the shrink factor. So we'll have 4 dot in graph.subobjects. I think I can just do 4 dot in graph. But I'm not sure, so I'm going to print it out first. Yeah, so that works. And, wait, what did I end up doing? Why did it stop appearing now? There it is. Okay, so, 4... Oh, this shouldn't be here. That must have been why that was happening. First I'm going to place all the dots there. Then once they're all placed, I'm going to shrink them so that they fit. So I'm going to go for dot in graph. Get the coordinates. Dot chords. I'll just do plain dot point to chords of. I'll just do plain dot point to chords of the dot center. Okay, so that gives me the coordinates. I'll actually make this dot x and dot y. Then I'm going to move the dot plain dot chords to point. So I'll have to pass in the coordinates that I want it to be at. So the x value I want to be shrunk, so I'll multiply that by the shrink factor. And the y value I want to be the same. Okay. So with luck, what we'll see is that as points are added to the graph, they'll be shrunk down. And I believe this is working now. 10 divided by time. It seems like it's actually not by enough. Oh, time times flips per second. Great. So what's happening here is the total x length, or the total distance in x that these dots are going to be, is going to be time times flips per second because I'm adding more than one each second. That's why I'd have to do that. Okay. So now these are growing. That's good. I'm going to want to add some lines between these so that it'll sort of trace out the changing probability. So I'll do that next. So I'll say for dot in graph starting from 1. I'll say, actually have this lines array back here. I'll do lines dot append a line. Oh, I guess I need the start and the end. So what I want to do is start, comma, end. Then I'll do graph, not including -1. A zip of graph not including -1, and then graph from 1 onwards. This will just be start.getCenter, and then end.getCenter. Then I can do graph.subobjects equals lines plus graph.subobjects. Okay, and hopefully now you can see the lines trace this out. So that's a pretty nice animation. Let me make this go a little faster by increasing the flips per second. Make it take a little longer too. Great. So what you'll notice is it's tracing out the same path every time. That happens because in Manim, by default, as soon as you import Manim, it'll automatically set a fixed seed for you. So I don't want that to happen in this case, so I'm going to say random.seed. I'll do, I think it's time.time. Then I have to import time. And now hopefully we'll see a different path. Great. So there's a different one. So you can see this is converging to about where you expect 0.5 to be. Just to make sure we get it exact, I'm going to add in a 0.5 line. So I'll say half line. This will be a line, and the start will be chords to point. I'll have that at 0, 1.1, 0, 0.5. Then going from there to, I'll have that at 0, 1.1, 0, 0.5. Then going from there to plain dot chords to point of 10, 0.5. Then I'll add that. Okay, and that should just show us the value that this line or this graph is converging toward. Great. And I'll increase the flips per second, by which I mean double. And you can see that, yeah, luckily math works, and we can in fact see that this graph is converging toward a half. Great. One sort of interesting, rather instructive thing you can do is you can change the values that you're sampling, like this. And when I do that, that's going to move this noticeably down toward 0.33. So then this one, you can tell, oh man, hold on. I meant to loop it. So then this one you can see, well, I guess there's a rather anomalous, like 15 tails in a row, but you can tell that this one's going toward 0.3. Okay. Cool. So next, I'll move on to the next one. And the next one is going to be about approximating pi. All right. I'll update this too. All right, so as you may know, you can approximate the value of pi by drawing a circle within a square and then sampling points within the square and comparing the number that are inside the circle to the number that are inside the square. If that didn't make sense, just from the description, you'll see in a little bit. So I'm going to start with a square. And I'll scale it. I'll just have a scale factor variable, because I know this will come in handy later. And a circle. Add both of these. Wait. Now I should see a square and a circle. Simple enough. Let me just set the color of this one. Not to right, but to red. And this one, circle be blue. So I'll check that. All right, and this makes sense too. So now we're going to want to sample points within the interior of the square. So for one thing, we're going to need essentially a clock. So I'll have a time tracker, value tracker, and then I'll the self.play. Have a time tracker.animate. And I'll run this for 5 seconds at first. So this should look exactly the same as before. Yeah, just making sure it doesn't crash. Now, what we'll want to do is on each frame, and I have to do this with an updater. Sample a point within randomly inside the square. So to start, I'll just have an array of points here. And I'll say, actually, like before, I'll just start it with something. No, I'll just do it this way. When we're updating this, we're gonna get the time. Time tracker dot get value. Okay, then if the number of points is less than the time, and I'll do a points per second later. The number of points